All right, we're back. Learn Python 3 the hard way, exercise 4, where we learn the next little concept, which is variables and names. The scripts you've been making have been very lame. They just print things, which is fine. You do a lot of printing, you do a lot of strings in any programming you do, but we need some variables. We need a way to work with data to do stuff, right? Just using numbers doesn't help. So once you type this in, I've got Adam over here, and after this exercise, I'm going to retire Adam and use Visual Studio Code. Maybe Adam will have guest appearances later, but for the most part, I'm just going to use Visual Studio Code. If you're on any other platform, remember, Visual Studio Code also works on Linux, it works on OS X, it works pretty much everywhere. So once I have this typed in, remember, you want to make it exact. Now we can sit down to sort of analyze how Python does this. So what Python's doing is it's starting at the top, all right? And it's going down. But these here don't particularly seem to do anything. Now the print lines, those do something. It's very obvious. And let's just go and run it really quick. So if we do Python ex4.py, you can see, there we go. It runs it, it does a thing, but it's only printing out what's in these 11 lines. So what's going on? When you run this, you're still giving Python a command, but what you're doing is you're telling Python to create a piece of data and give it a name. In this case, we're creating a piece of data that's set to the number 100, and we're naming it cars. And then we set it to another one, 4.0, call that space in cars. Notice I have to do this underscore. That's because if I do this, let's try that. Let's say I do that. Python doesn't know what we mean when we add that little space there. Okay, there should be something there. So if I run that, I should get a syntax error. Okay, so if we want to have spaces, right, then what we've got to do is we use an underscore to sort of simulate a space. When I get to this line, it's the same thing. Python's just sort of creating memory. It's creating data to store. And now once we have that, Python can get to this line and use that data to perform calculations. So when we say this, we read this from the right is the way to read this. We're going to say cars.driven is set to, or now equals, cars, which we set up at line 1 to 100, minus drivers, which we set to 30 up at line 3. So one way to think about this, it's not entirely correct, but one way to think about this is when Python encounters the word cars, it jumps back up to here and sees, oh, you set that to 100, and then it plugs 100 in there. That's one way to look at it. Another way to look at it is you told Python on line 1, hey, remember, whenever I say cars, that equals 100. And remember, whenever I say drivers, that equals 30. So now I'm going to come here, you're saying like, Python, remember when I said cars equals 100? Put that here. Whenever I see drivers, put 30 there. Does that calculation and then assigns that to cars not driven. And so on and so forth. Cars driven equals drivers, carpool capacity, and so on. Keep in mind, this is complete nonsense math. I'm just making this all up. One of the things I do in this is I use nonsense math, so you focus less on the math and more on how the words are used and the symbols are used. Now, when I get down to the prints, it's the same thing. Python, you know how the comma works. It's sort of like saying and then, you know, or a list in English. But now, when Python encounters cars, it goes, oh, you wanted me to remember cars is 100, so it puts it there. And it says, you wanted me to remember drivers, and puts it there. Drivers is 30. And then it goes, oh, and you wanted me to remember cars not driven is set to cars minus drivers. And so on and so forth. And that's how that code works. Now, let's modify some of this. So let's make sure it still works, because I did some changes. And we can do additional calculations. I can do like that, and we can watch all the numbers change. Let's try it. Yeah, now it says we can transport 600 people. Let's try another one. Let's undo that. I'm hitting Control Z to undo that. Let's try, let's do a really common error. I'm going to get rid of that one S. And trust me on this. The most common error you're ever going to run into, one character errors are the bane of every programmer. So let's try that. Now we have a new error type, name error. The name error is significant. It's important because when you run into a name error, that means you spelled something wrong in one of two places. Every time you get a name error, you either spelled it wrong where you did equals, where you set it equal, or where you use it. So if I do this, let me get rid of the S there, means I spelled it wrong. Name error is not defined. If I come up here and I do it this way, I misspelled it there, I get it at the same location. I fix it because it's down there. So I have two choices. If I do name error here, if I come down here and I have a name error, like that, I look for the line number, line 16, and remember, those line numbers are clues. A lot of people who start out coding, they see line 16 and they zero in on this tiny little piece here. For them, this is everything. This is everything they need to do. Let me just increase this font for you. Oh yeah, that's way better. Everything they want to do, they just focus on this one line. I can't see the error. 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 Remember, it's a clue. You can't see the error on here. So now you got to come up and you go, okay, well, what did I call this? And I guarantee you will miss this one missing character over and over. So what you got to do is just look at all the characters, or sometimes you can do this. I'll show you a little trick. I'm going to grab this variable that says name error. Okay. I know I've defined it because I'm not seeing that missing S. Paste it underneath really quick. And now you can see the missing S because you can go character by character and you see it right there. Once you do that, Control Z that out of the way and fix it down where it is. Another way to do it is if you do Control F, you can search, and then what you want to do is you want to do average, or even just paste in what I just did. Oh, this way. And see how it's not found? So you know that that can't be there. All right. Now, let's see. And by the way, I got that find window by Control F and hit escape to get rid of it. Okay, so we've got all this. Let's make sure we fixed it. Now, what you should do is take the script and again, break it, modify it, try to make changes. Whenever you make a change, try to guess what's going to happen. Don't just make a change and see what happens. Try to make a guess. And then if the guess is different from what actually happens, go find out why. Okay, that's the end of exercise 4. After this, I'm going to switch to Visual Studio Code. As you can see, it's pretty much the same. I mean, it's shockingly the same, so trust me. But I'm going to use it because it seems to be working a little bit better with Windows, and I don't want to run 2 text editors, and these text editors are a little large, so they can really work the machine. So I'm going to just get out of Atom. Oh, let me show you one quick thing. If you want to jump files really quick, hold down Control. This is in Atom. Hold down Control, hit T, and up comes your files. And then you can jump to them. It's pretty easy. So then you can get rid of the files on the right and do Control T to get to all your files. There you go. Okay, so that's the end of that. I'm just going to get out of Atom. I believe Visual Studio Code. Let's see if they got the same thing. Yep, it's sort of a universal thing that you can do. Okay, that's the end of exercise 4. Now I will see you at the next exercise.